Number 15. Word problem? Ooh, the difference. Okay. The difference between 6 times a number and 7 is 49. Okay. The difference between 6 times a number. So first off, what does the word difference mean in math? Subtract. So I'm going to have a subtraction sign. So I know that so far. I know that is in math means equals. So so far I know that. So the difference between 6 times a number would be like 6x, and 7. So you're going to get 6x minus 7. So that's how I'd kind of go through. A lot of times students might mix up. They might have 7 minus 6x. So just be cautious about how you do it. Sometimes it makes sense if you read it a couple times going, okay, let's start putting stuff that I know. And that's why I put like the equals, I put the minus, and trying to decipher some things. So we just know that this was because of the is. This would have been because of the word difference. And then if we go and solve it, add 7 to both sides. So 6x, those cancel, is equal to negative 42. Divide by 6, divide by 6. So x is equal to negative 7. Is that okay? What else did you see that I can help you with? Yeah. Mm-hmm. Number 8.
Can I borrow a pencil?
Yeah.
My chair. Thank you.
Give it to me when you graduate. A couple years from now.
I know. I'm just confused.
All right. Do you want me to do it the way I was showing where I cleared the denominator? Does that kind of make sense?
This is your classroom. So there's another set of stairs that you could have gone up.
My classroom?
Hi.
Hello.
I'm giving a tour, yeah.
All right. Who are you touring?
I'm touring Daniel. Yeah.
Hey, how are you?
He was in your, actually, third period.
Third period. That's right.
I'll finish this tour first.
All right.
Let's go back up these stairs.
So let's get rid of this. If I multiply everything by 3, it's going to go away. Is that okay? Cancels out. So I get 24 is equal to k minus 6. And then add 6 to both sides. So 30 is equal to k. So I like that answer's fine. Some people like to have the letter first. It's your choice. Okay. What was the other one you said? 10? Okay. 10 is going to be done the same way, and I know these are ones I didn't assign, but it doesn't hurt you to take a look at them. Okay. Same thing. I have a denominator. I see a denominator. Let's just get rid of it before we do anything. So I have this whole term and this term. If I multiply this side by 4 and this by 4, those cancel away. And that's going to give me 44. Is that all right?
I got a question. I'm wondering what the other answer was again.
30.
Okay, I'm just going to write that down.
Okay. What did I do?
Sorry, that was when I made it.
Okay. I can go back to 15. Get it? 15. So it said that was the one that said you have difference. So I know it's going to be subtraction. And then is. So that's the is means equals in math. So I put those first. And then 6 times the number would be like 6x. 6 times something. And then 6 times the difference between 6 times the number and 7. So you go 6x minus 7. And then solve from there. Okay. Oh, wait. So we're still on this one. So let's put this. I'm going to subtract 5 from each side. Let's cancel. Divide each side by 3. So I think 3 goes into 39. I believe 13 times. Okay?
I wonder if you can keep it there for a second.
You got it. What other questions do you see? Yeah.
We do 19.
19. Ooh, another word problem. All right. So number 19 says you have 247 students that are traveling on a field trip. 7 students must travel in a chaperone's car. The remaining students are split evenly, filling 6 buses. How many students can fit in a bus? I think we did this one very similar. I don't know the exact wording, but I think it's a pretty identical problem. Did you get it? Got it. Cool. All right. So number 19. I know there's 247 students that are going to be on this trip. Okay. 7 of those students got there because they rode in someone else's car. But then we're going to add that to how many buses we had. So it said we had 6 buses. So if we go and solve that, we can just say, all right, I'm going to subtract 7 from each side. So 6b is equal to 240. Divide each side by 6. So it looks like each bus would have had 40 students. Okay, so 6 buses of 40 is 240. Add the 7, gets you the 247 on the trip. Does that make sense? Any other questions? Good. And again, I want to remind you, I'm available periods 2, 4, 6, or 8 to come in if you want to do homework with me. I've had quite a few students that have started coming in during off periods, getting their homework done. If you get your homework done with me, that means you don't have to do a math homework at home. Plus, I'm here to help you if you need help. Okay, happy to help, all right? If I'm not in this classroom, I'm right next door behind this flag. So come on in. If we get too many kids, we'll just come back over here. Yeah, question? Stretching? All right. All right, so let's get our notes out. I think you're first. Do what? 21 is the page. All right. Looks like a balance beam is the very first. Is that the first one? Okay. So.
I was gonna do one more.
Oh, don't worry about it. Did it switch it?
They're trying to.
Okay. I'm not worried about the warm-up. All right, so this is our first question, and they kind of have like this balance. Right now, this item is balanced. Okay, right down the center of this is our main item that we're balancing. So when I draw that dotted line, I basically have that. So what I do to one side, I do to the other. Okay? Whatever I do to one side of a problem, I have to do to the other side to keep it balanced, keep it equal. Okay? If I added 100 to both sides, or one side, it's not balanced. If I added 100 to both sides for whatever reason, it would still be balanced. Okay? So I'm not going to work this problem because I believe it's on the next slide. It might not be, but that's okay. So with that in mind, this is a similar type of problem we've been working with. Okay? You have the letter X on one side and the other on this equation. Agree? So what I want to do is I want to start moving things around. I have to get my X's on one side, and I have to get just my numbers on the other. So there's all kinds of places I could start this problem. But I might choose to move my 6X. Those are going to cancel out. That's going to leave me 3 equals 8 minus 6 is 2. To get that. Okay? So now I have X on one side. That works. Now we want just to not have any numbers attached to it. So then I'd probably choose to add 21 to both sides. Get there. What's my last step? Divide by 2 because 2 and X are being multiplied together. So if I divide each side by 2, that goes in that 12 times. Bless you. So I wind up getting X is equal to 12. Yay, y'all done? Thank you much. I'll put that in the grade book in about an hour. You got it. Thanks so much for coming in. I gave you the benefit of the doubt. Figured you got it. Okay. So, problem number 2. On my equal sign, there's a D on one side and there's a D on the other. Agree? So again, I'm going to just kind of throw this down. That represents the equal sign. So we know we have one side and the other. Whatever I do to one side, I have to do to the other side. So I think I might subtract D, which is the same thing as 1D, right? Those cancel out, so I get negative 7D equals 4. How are negative 7D being held together? Multiplication, so division undoes that. Those cancel, so I get D equals negative 4 over 7. The negative sign on these can be at the top, can be in the middle, or at the bottom, but there only needs to be one negative sign. Okay? And again, these are the solutions. If we plug these back in, we create true statements, meaning you get one number equals the exact same thing on the other side. That means you know you're dealing with the solution. May I move forward? Okay. All right, number 3. I have an equal sign. I'm just dropping that down. Hey, friends, do you have to draw that vertical line? I'm just putting it in place to show you that I have a left and a right side to it. Okay? So on this one, I might choose to subtract m, and subtract m, which is the same thing as 1m. So those cancel. So I get negative 5 is equal to 2m. Agree? How do I get m all by itself? Divide it. Good. So I know that m is equal to negative 5 halves. Leave your fractions as reduced. And if they are improper, leave them as improper. Do not turn to mixed numbers. Do not make decimals. Rule of math starts with fractions, ends with fractions. Starts with decimals, ends with decimals. Cool? Now, would I say it's totally wrong if you gave me an answer of negative 2.5? No. Okay? Especially when you're using it on a calculator. A lot of students divide it out. But if you get a decimal that's like this long, think of it as a fraction. Cool? All right, problem number 4. I happen to have k on both sides of the equal sign. Agree? So, talk to me, friends. What do you think you want to start with? Where do you want to subtract? Okay, which k? Well, I don't want to move the 7 to the right and the... Pick one. Right one? Say, I'll subtract 5k from both sides. Those cancel. 2k minus 4 equals 16. Why's your... Do you want me to walk up there? I can. Okay. Anyone else need me to walk the phone up? Shame on Stirrup. Mine wasn't even up there. You guys are supposed to remind me. All right. What's next? I have k on one side. Agreed? What should I do? Add 4? Like it. Add 4 to both sides. Those cancel. 2k equals 20, I believe. Divide each side by 2. How many times does 2 go into 20? K is 10. It's our solution. Seem okay? Do we have more notes? 2 more? All right, we can do that. What time are we out of here? 11? Oh, we got plenty of time. Okay. I have an A on both sides on number 5. Subtract 4A. Or add 4A. Add 4A. Good. Add 4A. So I get 10. Is that negative 4a now? Equals 5. Did I do that right? Okay, cool. Yeah, negative 8 plus 4 is negative 4. Subtract 10. Last step. Yeah. That's how I make my A's. My 2 looks like this. What should I do last? Yeah, divide each side by negative 4. Hey, what's negative over negative? Positive. So if you have a negative over negative, these convert to a positive number. So then you just leave it as A equals 5 over 4. Last problem. So let's notice something before we go too much further. I have this, and I have this. So one of the sides I happen to have like terms. Agreed? Okay, so let's take care of like terms first. So I get 6m minus 5 equals 6m plus 7. Agree? All right. What do you want to do? What should we do? Subtract 6m. What's going to happen? Yeah, that cancels and that cancels. Uh-oh. Did we just discover one of the great lifelong secrets of math, that negative 5 is actually equal to 7? Or is that complete nonsense? Nonsense. This is no solution. Okay? This is a false statement. So if all of my letters go away and I get 2 completely different answers on each side, and you don't have any more letters, you just have number equals number, and one number is not the same as the other, that is totally false. That means you have no solution. Now, I have a question, though. Let's say this is kind of just an addendum to it. Let me get to the end of these. What happens if I had, say, something like this? So it's still the 6m, right? What happens here? Is that true? Is 5 equal to 5? That's true. If that happens, this means you have infinite solutions. Now, I want to show you why these work the way they're working. Okay? So I'm going to, we're not required to use this, but I just want to show you why this works. Okay, this would be like we have 2x plus 3 on the left side, and we have 2x minus 7 on the right side. So if I graph it, what do you notice about the red and the blue line? They're parallel. Do parallel lines cross? No, that's why there's no solution. No, then there are some math classes, but not, they're called non-Euclidean. We're dealing with Euclidean math, which there's basically 5 properties that exist. So in Euclidean math, this will never cross. In non-Euclidean world, where one of the 5 axioms, which are rules in math, one of the rules doesn't work, you would get parallel lines to intersect. But you don't have to worry about that now. If you have parallel lines, they won't cross. All right, now, if I did the same thing, that's the exact same equation, right? So if I had 2x plus 3 on the left and 2x plus 3 on the right, And I solved it and I got 3 equals 3. That means infinite solutions. This is what the graph looks like. 1. Oh, wait a minute. The red and the blue are right on top of each other. So it's continuously touching. So that means there's infinite solutions. If I change, say, this to a 4, and I graph it, see how they cross each other? That's where your solution's taking place graphically. No, you don't have to know the graphic. I just wanted to show you, give you a little visual representation of what's taking place. Okay? Questions for me, my friends? Yeah. Yeah.
I'm still confused about how this sort of makes sense. How does it like make sense to Andy and Horace?
How do you get what? You don't have to know how to graph on a calculator. It's okay. So I'm just giving you a visual representation. All the ones that we got, like x equals 6 or x equals 2 or something like that, or a equals, would be 2 lines crossing. If you had everything falls out, all the x's are gone, and you get 5 equals 5, you have 2 lines that are the same laying on top of each other. If you want to get like 10 equals 7, you got parallel lines. So that's basically the difference. So, all right. For Monday, 6, all right. Yeah, it's Friday, right? Isn't it? If it's not, if you're like, no, Stirrup, it's Wednesday, uh-oh, I'm in trouble. I made plans for tomorrow. No, I'm going to actually give you the next page. Don't worry about the evens on the last one. If you did them all, great. But I'd like you to do page 23 and 24. And I think you can do 1 through 13. That's all of them. Okay? But